Hello friends, and welcome to the another session of progressions. In the last video we have seen some important concepts in progressions like arithmetic and geometric series and some special series. So let's solve some examples on this kind of series. So these are the few formulas that we must remember. The first one is the sum of the first n terms, which is given as n into n plus 1 by 2. The second one is the sum of the squares of the first n terms, which is equal to n into n plus 1 into 2n plus 1 by 6. While the third one is the sum of the cubes of the first n term, which is given as n into n plus 1 by 2 whole square. Alright. Now the arithmetic or geometric series is, as we have seen, a combination of an arithmetic series, in this case a plus d, a plus 2d, a plus 3d, and also the characteristics of geometric series, which means the common ratio is also there in each of the term. Alright, so let's solve few examples on this kind of problem. Now sum to infinity of the series 2 plus 5x plus 8x square plus 11x cube is to be found. So let us see how we can solve this problem. Now, as we can see that the series is of the form APGP, that is AGP, arithmetic geometric series, as 2, 5, 8, 11 forms the arithmetic progression, while x square, x cube forms the geometric progressions. So let's say that the sum be denoted by Sn, which is equal to 2 plus 5x plus 8x square plus 11x cube and so on. Now we will multiply this equation 1 by the common ratio, which is x. Alright, this is an important step here, that we must always multiply the sum by its common ratio, which is in this case x. So we get x of Sn is equal to 2x, 5x square, 8x cube and so on. Now we will subtract equation 1 and 2. So we get 1 minus x times Sn is equal to 2. Alright, 5x plus 5x minus 2x would be 3x, 8x square minus 5x square would be 3x square, 3x cube and so on. Alright, now if we look carefully, 3x square plus 3x plus 3x square and so on forms a geometric series with the first term as 3x and it is up to infinity. So we apply the formula for sum to infinity of a geometric series, which is a upon 1 minus r, which gives us 3x upon 1 minus x. And if we transfer 1 minus x to the right hand side and solve, we get the final answer as 2 plus x upon 1 minus x the whole square. Okay, we will solve one more problem on this one, so that you get a clear idea on how to solve this kind of problem. Now sum to infinity of the series 1 square plus 2 square x plus 3 square x square up to infinity is to be found. So give this problem a try and then we'll see how this can be solved. Okay, let's solve the problem. Now, though the given series is not in arithmetic or geometric series, it can be summed up in a very similar fashion. We can see that the terms or the coefficient of x are in terms of square. Alright, so in this case also we will use the same technique. Alright, so s is equal to 1 plus 4x plus 9x square plus 16x cube and so on. Okay, now multiplying this series with the common ratio, we get Sx is equal to x plus 4x square plus 9x cube and so on. And if we subtract the two series, we get 1 minus x times s is equal to 1 plus 3x plus 5x square plus 17x cube and so on. Alright, this would be 7x cube. Alright, so if you observe closely, now we have got the arithmetic or geometric series. Alright, so now we apply the same technique to solve the arithmetic or geometric series. That is, we multiply the series by the common ratio, which is x, and we get the series as x plus 3x square plus 5x cube and so on. And then we subtract the series from equation 1. This is the series 1 and this is the series 2. Alright, so we get the final answer as s is equal to 1 plus x upon 1 minus x the whole cube. Alright, okay, let's solve one more problem. Find the sum of the series 2 into 5 plus 5 into 8 plus 8 into 11 and so on up to n terms. So try to solve this problem and then we'll see how we can solve this one. Alright, let's solve the problem. Now this series is formed by multiplying the corresponding terms of sequences 2, 5, 8 and 5, 8, 11, both of which are in AP. We can see that the first term 2 of series 1 is multiplied by the first term of the series 2, which is 5. Similarly, second term 5 is multiplied by second term 8 and so on. Now nth term of the first AP is given as 2 plus n minus 1 times 3, as the common difference is 3, which is 3n minus 1. Similarly, the nth term of the second AP is given as 5 plus n minus 1 times 3, which is 3n plus 2. Alright, thus the nth term of the given series would be the nth term of first series multiplied by the nth term of the second series, which is 3n minus 1 into 3n plus 2, which on further simplification becomes 9n square plus 3n minus 2. Thus, we can find the required sum as the summation of nth term as summation of 9n square plus 3n minus 2. Now, we have the formula for sum of the first n terms, sum of the first squares of the n terms and sum of the first n cubes. Alright, so we will use those formula here and put the formulas here and simplify to get the final answer as n into 3n square plus 6n plus 1 by 2. Okay, let's solve another problem. Find the sum of first n terms of the series 1 plus 2 plus 1 plus 2 plus 3 plus up to n terms. Alright, try to solve this problem on your own and then we'll see how we can solve this one. Okay, let's solve the problem. Now, nth term of the given series can be found as Tn is equal to 1 plus 2 plus 3 up to n. How we derive this one? Let's look at this. If you look at the first term, we can see the first term is simply 1. If you look at the second term, then second term is nothing but the sum of first two terms. The third term is similarly the sum of first three terms. So the nth term would be the sum of the first n terms, which is given by n into n plus 1 by 2. This would be the nth term. Alright, now we have to find the sum of all such n terms. So we will find the sum of the nth term as sum of half n square plus half n, which on simplification and putting the values for summation n square and summation n will give us half n into n plus 1 into 2n plus 1 by 6 plus half into n into n plus 1 by 2, which on further simplification will come out to be n into n plus 1 into n plus 2 by 6. Okay, so we have seen how to solve arithmetical and geometric progression, as well as we have seen some problems on the miscellaneous series, which is the sum of first n terms, the first sum of the first n square terms, while the sum of the first cubes of the first n terms. Alright, hope you have understood the video. If not, please replay the video as many times as you want to and get a clear understanding of the concept. Thank you.